All right. Um, I'm just gonna go ahead and start doing the practice tests until people have questions. Whenever you want, put it in the chat or just email me, and I'll stop whatever I'm doing after that. Do the problem and go directly to that one. I can't do the first two because it's not gonna make sense. Just different screens and stuff. I'm hoping that we can measure segments and measure angles. Keep in mind that those protractors will be given to you. All right. We practice that a lot in class. I'm confident in you guys that you're able to do that. So I'm just going to start with the distance problem, which is number 3. So the distance formula is this whole thing. So if we plug in x1, y1, and x2, y2, we get this. When we simplify that, -4 times -4 is 16. -8 plus 6 is -2, so -2 squared. So we get the square root of 20. Again, I don't want you using decimals, so to simplify this, I always make a factor tree. So because 2 show up, this is equal to 2 root 5. This problem is a little bit more involved, not much. It's the same problem as what's in green, except you have to get the 2 points on your own. So this first point, that looks like -3, 2. And the second point is 4, positive 3. So then we just do what we did in green all over again. Same formula. Four minus -3 is 7. 7 squared is 49. 3 minus 2 is positive 1. 1 squared is just still 1. So this is square root of 50. And our goal here is to pull out perfect square factors. So perfect square factors of 50 is 25, so we can rewrite this as 25 and 2. Square root of 25 is 5, and then the square root of 2 is left over. So this is our answer. Again, I'm not giving this to you. You have to memorize this. 5 and 6 classify each angle as acute, obtuse, right, or straight. Acute angles are angles who are less than 90 degrees. This is acute. 34 is also less than 90 degrees, so this is also acute. Just as kind of somewhat of a reference. Right angles are always denoted like so. And their measures are equal to 90 degrees. I'm just pretending that there's some angle that we're talking about. How do the two twos in the factor tree work? We're talking about in green. So when we have the square root of 20, we're trying to pull out perfect squares. All right. So a perfect square factor of 20 is 4. So you can actually make this a little bit simpler. This can be the square root of 4 times the square root of 5. Square root of 4 is 2. Square root of 5 just stays the same. I like doing it as a factor tree because any factor that shows up twice, that factor, that whatever number that is, just ends up on the outside. So you're just you're taking factors of the entire thing. Okay, and hopefully one of those factors are a perfect square. That perfect square, you take the square root of it and ends up on the outside. Number 9 and 10. Sorry, this is not organized. Number 9. Number 9 says find the value of x given this right angle and these two smaller angles. All right. So using our angle addition postulate, we know that 4x plus 3 plus 31, so the top angle plus the bottom angle is going to equal 90 degrees. We know that it's 90 degrees because of this marking right here, which you now can't really see because I drew over it. Once we have this equation set up, then we just solve for x. So 4x plus 34 is equal to 90. 4x is equal to 56 if we subtract 34 from both sides. And then if we divide both sides by 4, we get x is equal to 14. Yeah. So number 9 relies on you knowing that you can add these two angles together to get a 90-degree angle. Also, just as a review on number 9, this angle and this angle, because they add up to 90 degrees, these are considered complementary. Number 10 says find the measure of angle B. So this big angle and this small angle, these form a linear pair because their non-common side form opposite rays. Alright, so that's a straight line. Okay, so the angles inside of it add up to 180. So if we set up an equation, we get 151 degrees plus b degrees is equal to 180. So these are both a linear pair and supplementary. So then we just subtract 151 from both sides. So b is equal to 29. And that's our answer. So number 9 and 10 kind of rely on a couple of definitions that you guys should just know. 10, linear pair and supplementary. 9, complementary, and whatever we did with the angle addition postulate. And that also goes for number 10. Spectre number 5 and 6. We went over right angle. Obtuse angle is anything over 90 degrees. So the measure of a some angle, we'll call this one B, is going to be greater than 90. And then acute, well, these are acute, is anything less than 90. And then there's the straight angle, which is just a straight line. So all 4 of these are fair game. Number 7 says draw and label an angle to fit each description. An obtuse angle TUV. So first we need to draw an obtuse angle. So this angle has to be greater than 90, whatever it is. And again, because I'm giving you guys protractors, it should be like pretty obvious that it's over 90 degrees, right? So then we need to label this as TUV. So U, the middle letter, has to be the middle, that has to be the vertex. So this point has to be U. And then normally I just go left to right. So we can label this T and this V. So this angle is an obtuse angle and it is TUV. Number 8, find the measure of angle B. This is just like number 9, except there's no x's involved. So 64 plus B should equal to 90. We know this because of this indicator right here. That tells us that that entire angle is 90 degrees. So if we do that, we just subtract 64 from both sides. So we get 26. Alright, difference between a regular polygon, equiangular polygon, and equilateral polygon. Each of these has its own unique definition. Alright, so a regular polygon, well, I'll start with equilateral. I don't know if there's two L's in that, but we're going to pretend like there is. An equilateral polygon is a polygon in which all of its sides are congruent. Equiangular is a polygon in which all of its angles are congruent. And then regular is a polygon that is equilateral equiangular and convex. Okay, so we need definition. We need to draw each of these definitions basically. Jacob, I will go back, but let me explain 17 to 19 first. 17 to 19, again, you guys have, you're gonna have a protractor. So I expect these to be, again, somewhat mostly accurate. Alright, so a regular polygon, the easiest one to draw is a square. Mine's not going to be perfect. I have no way to draw angles or any ruler near me. So regular polygon, I always think square. Okay, I'm pretending that each of these sides are congruent. And we can mark that like so. And I'm also, a regular polygon also has congruent angles. So all of these angles would have the same measure. An equiangular polygon that is not regular, the simplest definition of the, or the simplest figure of this is a rectangle. Okay, a rectangle doesn't have congruent sides. The top and bottom sides are congruent, and the left and right sides are congruent. But they do have congruent angles. And you can get creative with this. I would rather you not draw a square and rectangle, but those do work. And then an equilateral polygon that is not regular. So we need sides that are congruent but angles that are not. And the one I always go to is a parallelogram. So imagine that all these sides are congruent. I know that's not exactly what you want, but none of these angles are congruent with one another. So all the sides are congruent, but not all the angles are congruent. So therefore it is equilateral, but not regular. You could also be clever and draw a equilateral polygon that is not convex. So think something like that. This would also work. Right? This is equilateral but not equiangular, so not regular. Which is also not convex, so it doesn't meet any of the definitions but equilateral. Jacob, what are your questions on 5 and 6? I'll do 15 and 16 and then um, distance again. We did already go over distance, so if you want to like scroll back through the video, you can actually find it. If not, I can do it later, but we did already go over it. Just as proof. There it is. But I can go over it again. But for now, 15 and 16. Okay, 15 and 16. Write the name of each polygon and label it as concave or convex. So in order to get the name of a polygon, count the sides. 1, 2, 3, 4, 5, 6. So number 15, that's an 8-sided polygon, so automatically this is going to be some kind of hexagon. Okay. If we extended each of these sides, in order for it to be convex, none of the sides would hit the interior of the polygon. Both of these sides do. So if you were to extend both of these sides, this one and this one, the lines that they extend to hit the interior of the polygon. So this is concave. So this is a concave hexagon. Sorry. Yeah, you're right. This is an octagon. Number 16, again, just count the sides. This is a 9-gon. There is a name for it. I did not tell you to memorize it, though. So I would expect a 9-gon. If you were to extend all the sides, none of these lines would hit the interior, so it is convex. So this is a convex 9-gon. If you know the name of the 9-gon, you can say it, but I'm not going to make you memorize it. So Sam, distance. You have to know the distance formula. Which is the difference between the x's squared plus the difference between the y's squared. Alright, so in number 3, this is This is the practice. Okay, this is the practice test I gave you. Number 3, this first point is x1, y1. This second point is x2, y2. So you just plug those numbers in. So d in this case is equal to -2 minus 0 squared plus -4 minus 7 squared. -2 squared is 4. -4 minus 7 is 11. 11 squared is 121. 4 plus 121 is 125. And then we need to simplify, and this is like the harder part that I think people are getting confused about. In order to simplify this, we want to break it down into factors where 1 is a perfect square. Okay, so we need a factor tree where one of the factors we pull out is a perfect square. Okay. 25 goes into 125. And it goes into 125 5 times. So we can rewrite the square root of 125 as the square root of 25 times the square root of 5. And then we simplify from there. Square root of 25 is just 5. And the square root of 5 we can't simplify anymore, so that just stays as is. So our answer is 5 root 5. Number 4 is the same problem. You just have one more step, which is to identify these 2 points. Once you identify the 2 points, then you plug and chug. So just starting where I left off, 11, find the value of x. This is kind of similar to number 9 and 10. (137), so this angle and this angle form a linear pair. And so they are supplementary. So 137 plus x plus 21 is equal to 180. And then we do some work and solve for x. So 137 plus 21 is 158. We subtract 158 from both sides to get 22. And then that's our answer. Number 12. This angle and this angle form vertical angles. Vertical angles are always congruent, so we know that 77 is equal to 2x plus 1. And then again, we just solve for x. So subtracting 1 from both sides, we get 76 is equal to 2x. Divide both sides by 2, so we get 38. So we did 17, 18, 19. Number 20, find the area of each. So the area of a circle, A is equal to pi r squared. R is 11 in this case, so A is equal to pi times 11 squared, which is equal to 121 pi. Again, I don't want you to write this in a calculator and get a decimal. I want this answer. Number 13, again, you just count the sides. We just skipped around a bunch. That's okay. 13, count the sides. So this is a pentagon. And it is concave. So there's a concave pentagon. Again, we know it's concave because if we were to extend this side, that line goes through the interior. Yes, you have to memorize the formulas for circles. I'll get to 21 here in a second. That'll clear it up a little bit. Number 14. This is also a pentagon, because there are 5 sides, and it is convex. So this is a convex pentagon. Find the circumference of each circle. Circumference is equal to 2 pi r. So 2 pi times the radius. Our radius in this case is 2. So c is equal to 2 pi times 2. If we multiply 2 by 2, we get 4. So c is equal to 4 pi. Find the diameter of each circle. Diameter is just twice the radius. So 9 is the radius. So our diameter is just 18. Find the area of each. The area of a triangle is A is equal to 1/2 base times height. In this case, our base is 10.7 and our height is 7.3. So area is equal to 1/2 10.7 times 7.3. So if we plug that into a calculator, we get 39.055. And that would be inches squared. The area of a rectangle is base times height. Or length times width, whatever you want to call it. So 6.3 could be the base. 5.7 could be the height. Plug that into a calculator. get 35.91 inches squared. Area of a square, again, it's just base times height. So it's 8 kilometers times 8 kilometers, which is 64 kilometers squared. And then I think the last question on there is something like, given a square of area, let's say 64 kilometers squared, just to keep it simple, what is the perimeter? Well, if we know the area is 64 kilometers squared, we know that's some side times itself. So S in this case would equal 8. So one side is 8 kilometers. That means each side is 8 kilometers. So the perimeter is 4 times 8, which is 32. So given that there's only 2 other people on, I'll stay in for the next like 5 minutes or so. If you guys have any questions, just let me know and I can go over it. If not, then I'll end it there. So we'll say at 8:50, if no one asks questions, I'll call it. Names of polygons, we need to know three, 4, 5, 6, 8, and 10, and then n. So 3 sides is a triangle. 4 sides, rectangle, quadrilateral. Five is a pentagon. 6 is a hexagon. 8 is an octagon. 10 is a decagon. And then if there are n sides past that, it's an n-gon. So you gotta know those. In terms of ending an answer with a form of measurement, you really should. Am I gonna take points off for it? Probably not. It's a good habit to get into though, especially as you go into further chemistry and then physics. Physics is a big one. Physics teachers usually yell at math teachers for not reinforcing that, but I just care that, well, I care that you know both, but I really care that you know the math behind it. So yes, you should. Am I going to take points off? No. All right. It is 8:50 right now. It doesn't seem like many other people have questions. That there's only one other person on than me. So I'm gonna call it right there. If you have any other questions, email me, or go back and rewind in the video. I went over every problem and explained it pretty well, I think. Um, but yeah, so we'll end it there.